Segment 1, Introduction. Chemical reactions are the foundation of all life. They are the processes by which atoms and molecules are rearranged to form new substances. Chemical reactions can be simple, like the burning of a match, or complex, like the photosynthesis that occurs in plants. Some chemical reactions are very unusual and can produce surprising results. One example is the Belousov-Zhabotinsky reaction, BZ reaction, which produces oscillating patterns of colors. Another example is the reaction between gloves and capsaicin, which can be used to create self-heating gloves. This paper will explore 5 weird chemical reactions, including the BZ reaction and the glove-capsaicin reaction. It will also discuss the science behind these reactions and their potential applications. Why are weird chemical reactions interesting? Weird chemical reactions are interesting because they challenge our understanding of the world around us. They show us that there is still much to learn about the science of chemistry. Additionally, weird chemical reactions can have surprising and unexpected applications. What are the benefits of studying weird chemical reactions? By studying weird chemical reactions, we can learn more about the fundamental principles of chemistry. We can also develop new technologies that can be used to benefit society. For example, the BZ reaction could be used to develop new types of displays, such as self-patterning screens. The glove-capsaicin reaction could be used to create new types of medical treatments, such as treatments for arthritis. Conclusion: weird chemical reactions are fascinating and important. By studying these reactions, we can learn more about the science of chemistry and develop new technologies that can benefit society. Segment 2, the Belousov-Zhabotinsky reaction. The Belousov-Zhabotinsky reaction, BZ reaction, is a chemical reaction that produces oscillating patterns of colors. It is a complex reaction that involves many different chemicals, but the basic idea is that the reaction produces 2 different types of molecules, which then react with each other to produce the oscillating patterns. The BZ reaction can be carried out in a variety of ways. One common way is to mix the chemicals in a petri dish and then watch as the patterns form. The patterns can also be created in other ways, such as by dripping the chemicals onto a gel or by injecting them into a solution. The BZ reaction is a beautiful and fascinating example of a chemical reaction that can produce complex and dynamic patterns. It is also a useful tool for studying chemical kinetics and pattern formation. How does the BZ reaction work? The BZ reaction is a complex reaction that involves many different chemicals. However, the basic idea is that the reaction produces 2 different types of molecules, which then react with each other to produce the oscillating patterns. The 2 types of molecules are called the activator and the inhibitor. The activator molecule causes the reaction to speed up, while the inhibitor molecule causes the reaction to slow down. The 2 molecules compete with each other, and the result is an oscillating pattern of colors. What are the potential applications of the BZ reaction? The BZ reaction has a number of potential applications, including displays. The BZ reaction could be used to develop new types of displays, such as self-patterning screen. Materials. The BZ reaction could also be used to create new types of materials, such as self-healing materials. Medicine. The BZ reaction could also be used to develop new types of medical treatments, such as treatments for cancer. Conclusion: the Belousov-Zhabotinsky reaction is a fascinating and important chemical reaction. By studying this reaction, we can learn more about the science of chemistry and develop new technologies that can benefit society. Segment 3, the glove-capsaicin reaction. The reaction between gloves and capsaicin can be used to create self-heating gloves. Capsaicin is the active ingredient in chili peppers that gives them their heat. When capsaicin reacts with the chemicals in gloves, it produces a heat reaction. To create self-heating gloves, the gloves would first need to be soaked in a solution of capsaicin and other chemicals. The gloves would then need to be dried. Once the gloves are dry, they can be worn and will produce heat for several hours. How does the glove-capsaicin reaction work? The glove-capsaicin reaction is a complex reaction that involves many different chemicals. However, the basic idea is that the capsaicin reacts with the chemicals in the gloves to produce a heat reaction. The capsaicin molecule has a unique structure that allows it to bind to a receptor called TRPV1. TRPV1 is a receptor that is activated by heat. When capsaicin binds to TRPV1, it causes the receptor to open, which allows calcium ions to flow into the cell. The influx of calcium ions triggers a series of events that ultimately leads to the production of heat. What are the potential applications of the glove-capsaicin reaction? Self-heating gloves have a number of potential applications, including cold environments. Self-heating gloves could be used by people who work in cold environments, such as construction workers and farmers. Pain and stiffness. Self-heating gloves could also be used by people with arthritis or other conditions that cause pain and stiffness in the hands. Athletic performance. Self-heating gloves could also be used by athletes to improve their performance and reduce the risk of injury. Conclusion. The glove-capsaicin reaction is a fascinating and important chemical reaction. By studying this reaction, we can learn more about the science of chemistry and develop new technologies that can benefit society. Additional potential applications of self-heating gloves. Medical treatments. Self-heating gloves could also be used to develop new types of medical treatments, such as treatments for Raynaud's disease and other conditions that cause poor circulation. Personal comfort. Self-heating gloves could also be used to improve personal comfort, such as by providing warmth on cold days or during outdoor activities. Self-heating gloves are a promising new technology with a wide range of potential applications. By studying the glove-capsaicin reaction, we can develop new and even better self-heating gloves that can be used to improve people's lives. Segment 4. Other weird chemical reactions. In addition to the Belousov-Zhabotinsky reaction and the glove-capsaicin reaction, there are a number of other weird chemical reactions that are worth exploring. Here are two examples. The reaction between hydrogen peroxide and potassium iodide. This reaction produces a fountain of foam. The foam is created by the formation of oxygen gas. The reaction can be accelerated by adding a small amount of detergent. The iodine clock reaction. This reaction is a type of oscillating reaction, which means that it produces alternating periods of activity and rest. The reaction can be used to create a clock that keeps time by the changing colors of the solution. How do these reactions work? The reaction between hydrogen peroxide and potassium iodide is a complex reaction that involves many different chemicals. However, the basic idea is that the hydrogen peroxide decomposes to produce oxygen gas and water. The potassium iodide acts as a catalyst to speed up the reaction. The iodine clock reaction is also a complex reaction that involves many different chemicals. However, the basic idea is that the iodine reacts with the other chemicals in the solution to produce a series of oscillating reactions. The color of the solution changes depending on the form of the iodine present. What are the potential applications of these reactions? The reaction between hydrogen peroxide and potassium iodide could be used to create new types of fire extinguishers. The iodine clock reaction could be used to develop new types of chemical sensors. Conclusion. The chemical reactions discussed in this segment are just a few examples of the many weird and wonderful chemical reactions that exist. By studying these reactions, we can learn more about the science of chemistry and develop new technologies that can benefit society. Additional potential applications. The reaction between hydrogen peroxide and potassium iodide could also be used to create new types of cleaning products or disinfectants. The iodine clock reaction could also be used to develop new types of educational tools or toys. I hope you find this information interesting and informative. Segment 5. Conclusion. Chemical reactions can be both simple and complex, and they can produce a wide variety of results. Some chemical reactions are so unusual that they seem almost magical. However, there is always a scientific explanation for these reactions. The chemical reactions discussed in this paper are just a few examples of the many weird and wonderful chemical reactions that exist. By studying these reactions, we can learn more about the science of chemistry and develop new technologies that can benefit society. Here are some specific examples of how weird chemical reactions can be used to develop new technologies. The Belousov-Zhabotinsky reaction could be used to develop new types of displays, such as self-patterning screens. The glove-capsaicin reaction could be used to create new types of medical treatments, such as treatments for arthritis. The reaction between hydrogen peroxide and potassium iodide could be used to create new types of fire extinguishers. The iodine clock reaction could be used to develop new types of chemical sensors. In addition to these specific examples, weird chemical reactions can also inspire new ideas for scientific research and technological development. For example, the study of oscillating chemical reactions has led to the development of new methods for controlling and manipulating chemical systems. Overall, weird chemical reactions are a fascinating and important area of research. By studying these reactions, we can learn more about the science of chemistry and develop new technologies that can benefit society. I hope you enjoyed this exploration of weird chemical reactions.